Good morning and good afternoon, depending on where you are. Welcome to Unleash the Power of Smart Grid webinar provided by Silver Spring Networks. This is Scott Young, Senior Director of Software Applications at Silver Spring, and I'm here with my colleague Alex Zhang, who's Senior Product Manager for the SilverLink Sensor Network. We're here today to show you how you can leverage the Smart Grid's continuous connectivity to analyze network data faster at a lower cost, improve grid network operations, and increase customer engagement. Also like you to note that there's a Q&A widget at the bottom of your screen. We'd be happy to introduce and to do questions towards the end or in the middle, depending on when we get them. So feel free to ask questions, and we will go from there. The next slide you should be seeing is since we're a publicly traded company, we're presenting here. Anything that's presented represents a 12-month forward-looking view and is subject to change. And to learn more about the disclaimer, et cetera, please feel free to visit the website, SilverSpringNet, www.silverspringnet.com. So we've known for a really long time that our investment in the smart grid was basically aimed at leveraging meter to cache. And we spent a lot of time and we developed a lot of technology to enable that to happen. We've done quite a few things, but we know that there is quite a bit more value out there. So as we go through that, we look at where that value should come from, and we see all the applications that should begin to occur and have started to occur as a result of our investment in the smart grid. And we spent a lot of time trying to understand how to increase the speed at which we can make those investments and receive the benefit from what we've done with the smart grid. So if you kind of understand this slide, we've looked at what the benefit would normally be in looking at 130 million premises just in North America, and we see that value increasing pretty dramatically over time. The problem is the smart grid's been around for a while, and we haven't started to unlock a lot of that value yet. And so the critical question that comes up is how do we begin to unlock that value faster? And that's what a lot of this presentation is going to be about. When we try to understand why that value hasn't unlocked as quickly and as inexpensively as we think, we see a few really basic reasons behind it. We look at the architecture of the way things are currently connected, and we see companies and utilities, and primarily they're moving flat files back and forth. They've got a file-based system that's pretty fragile, and it requires a lot of integration and help just to get it going. There are really not that many standardized APIs out there that people have been able to leverage. And so when we start to produce and look at processing the data in production systems, we find out that all kinds of other activities are going on that involve the extraction, the transformation, and the loading of that information into other systems. Every single application requires a large amount of integration. From a head-end system to an MDMS, we see these things, and all those integrations require a lot of time, take time, and they're also very expensive. So it makes it really difficult to justify the expense of doing single apps, and we feel like that's a major reason why we've had difficulty advancing and leveraging the investment that we've currently made. When we look at the internal architecture of many of our utility customers, we see a lot of the same things. We see the MDMS as primarily a system that allows a large amount of data to transfer back into the system. But it's gated. It's about 70% of the utility data that's now coming over the AMI network is being used downstream in other applications. And everywhere you see one of those little lines, that's an integration effort, and that can cost millions of dollars. So if all this data is flowing off the network, we need to find a way to leverage it more effectively, we need to find a way to leverage it less expensively, and we need to find a way to leverage it faster. And those are kind of the three keys behind what we decided to do at Silver Spring to approach this problem. When we look at how other industries have solved this problem, we see some really interesting comparisons. And so if we look at the smart grid as a big network, and we know that there's a lot of intelligence out there at the edge of that network, there's also a lot of storage capability. We want to find a way to leverage that capability. And so when we look at what companies like Google have done in terms of addressing this problem, we see a lot of analogies with the internet. that are very, very interesting. So here's an example that I think will help us understand. We look at the CDC, and we see the old mechanism. They get reports from doctors and hospitals, and they collect their own data, and they try to map these things and understand how they're, and this process is fairly complicated and takes a fairly long amount of time. What Google decided to do was look at the network as the source of data, query that network, and figure out if they could map almost exactly to what the CDC was finding in terms of the response. So by the time they got finished, they constructed a query, not an application, not an integration, but just a query to map that data that was happening over the network, and they found a way to match what the CDC was doing. So as we click through and we map that, what is very interesting about this particular analogy is they were actually able to write this query inexpensively. They were able to take that query and map to the CDC's data almost exactly, but most importantly, they were able to do it on a prognostic basis ahead of when the CDC was actually producing the data. So the key here is that it's less expensive to write a query overall. It's much faster to do that in terms of integration efforts, and it takes you a lot less time to actually get that kind of data to make it actionable. So you'll hear us talk about near real time, and that becomes pretty critical to how the utility industry can take the data that's flowing off its network and actually leverage it in a more meaningful way. So what is the fundamental difference between how this process has worked in the past and is working now? When we started thinking about how to solve this problem, we looked at those analogies and we came back and we said, okay, so what's happening there is we're using standard kinds of interfaces. We're looking at lots and lots of endpoints or devices, and we're going to abstract away from those. We're going to create a software interface layer in between that's going to give us the ability to program that network. It just has to be anybody's network happening over the broad variety of things. So standard level interfaces on a programmatic basis into that network give us the ability to write queries against that network to get data. We also need to know that we have to integrate this with some of the back office systems as well. So simple interfaces and adapters there give us the ability to leverage the data flowing off the AMI network in a way that we haven't really been able to do before. That allows us to look at consumer apps and lots of other kinds of applications in a very different way than we did before, because we've simplified the process by which we're gathering that data. So that's a big chunk of the time that it would take to actually roll something out. But what it also does is it allows us to integrate things like IT/OT and to look at those streams of data in a standardized way, flowing into applications that can be produced more quickly and less expensively than ever before. Which leads us to the next set of solutions, which is we know there are lots of folks out there who are interested in supplying applications to the smart grid. And their ability to do that has been hampered in large degree by the complexity of that process in the past. We know that if you wanted to run a program, say you had a small theft application, you needed data out of some other system within the utility, you had to go find that person, you had to get permission to use it, and you had to get the keys to that system, and of course they told you no initially because that's always the normal response. The system wasn't designed to do that kind of stuff. You want near real-time processing, you want a separate slice of the data, and we're seeking to eliminate all that by providing those standard data flows on standard RESTful interfaces across a whole variety of apps to make it much more simple to look at the application itself as a way of using the data to accomplish a particular result, not most of the effort. What that allows us to do is essentially get lots and lots of apps manufactured less expensively and faster, and that's the key. So when we look at the idea of an app store, what we see is the possibility of these kinds of apps that are going to enable third parties to build on a common platform that's going to give them a way to combine a lot of the consumer grid and operational capabilities that they've always wanted to do because the data transformation has taken place at a different layer. And it's going to give the utilities the ability to deploy those apps much more quickly. We all know that data is the key behind most of these applications. And so being able to provide that data in a standardized format across a standardized interface to applications that are designed to consume it make that process much more simple and less expensive. So is it possible to build an app faster and easier? We think the answer is yes, and our experience has been indicative of that process as we've learned to leverage the network that produces the data and these common interfaces that we've been describing. So if we look at the old way of extracting and transforming and loading data into a variety of repositories, we see how those barriers get produced. The new way is radically different in some sense, but in other senses it's not. You just get the data that you need through basically a software-defined soft sensor. This sensor is a way of accessing through a common API or a common interface instead of having to deal with a bunch of flat files and moving them around. So it saves on the amount of time that you have for processing those, but it also saves on the amount of storage and so forth. But even more importantly, it allows you to mix and match the data that you need. It's not just historical data, but if you need to combine that with much data that's closer to real time, then that becomes available as well, and you have the ability to organize the query to pull that data that you need into that application where it's most appropriate. And so creating a generalized abstraction that allows this to happen is kind of the key behind how we move forward. So the question we often get asked is, okay, that sounds interesting. What is a soft sensor? So we've described it a little bit, but the data abstraction layer that's defined in software is the key. That software sensor allows us to be able to be tagged and to provide attributes and to fit context around that particular thing. So examples are pretty straightforward, zip code, class, location, service point, being able to combine those into specific data channels that allow us to take time series and recorded events and combine those with a variety of other things, contextualized, for example, to be able to include usage events and temperature, those kinds of things in a standard data channel that we can use to power an application to create an insight into what's happening. So the key here is that abstraction layer that lets you organize the data regardless of the source or the structure. So we've got a whole bunch of use cases to consider because I think in many respects the most important thing for us to do is to understand how those things work. And what I'm going to do is I'm going to turn the presentation over to Alex, and he's going to walk you through a bunch of those examples, show you how they work and how they can be implemented, and to basically put some meat around these bones.
Thanks very much, Scott. So this is Alex Zhang, I'm Product Manager at Silver Spring Networks. I'm going to walk you through a few example use cases that we talked about with customers in terms of powering on the Silverlink sensor network. So one of the ones that we hear most commonly is voltage. And voltage comes in from a lot of data sources into the utility back office today. But one of the things we are able to enable for the first time with the Silverlink sensor network is the ability to do very high frequency sampling of voltage on the AMI endpoint. So not only can you do very high frequency sampling on a 10-second interval, but you can also do distributed computation on the endpoint so that you can actually, instead of pulling back all of those 10-second intervals into your back office, look for interesting events right on the endpoint. So things like voltage sags and swells, calculating average voltages, looking at voltage across the service territory, those are all things that you can do as part of the network now because we're enabling this through the Silverlink sensor network. In addition, you can take voltage from multiple different data sources and use it to power a single application, regardless of the origin of the source of that voltage. Because we have a common API that sits on top of all these different data sources, you're able to power an application by programming against a single API for voltage instead of integrating separately with a DA system, an AMI system, a SCADA system, and all those different systems that you may need to power a voltage app. So some examples of what you might be able to do with a voltage sensor are things like voltage audits. If a customer calls in with a voltage problem, you can diagnose it remotely without having to send a truck to the premise to diagnose it. In addition, you can look at powering applications like conservation voltage reduction and using the application using the voltage sensor to show how you can power applications like that. We're going to give a quick example here of a voltage demonstration that we've built. You can see we've had some demo data put in here, but this is an example of a feeder topology. and you're able to dive in on that topology and see voltage at multiple different levels. So instead of just seeing voltage from a DA system or a SCADA system or an AMI system separately, you can overlay a single topology that helps you more quickly diagnose the root cause of any voltage issues that may occur. You can also look at a specific endpoint and see the voltage for that endpoint in the context of the broader topology and the broader voltage of your service territory. So that's one example with voltage that you can do using the Silverlink sensor network. And again, the great value of this is being able to more quickly program a voltage application by talking to a single API from multiple different systems instead of having to program against multiple different ones. The next example we're going to talk about very quickly here is meter temperature. Now, we've had a great partnership with some of our customers in developing a meter temperature feature that lets them monitor their entire service territory and look for exception meters that may be kind of trending towards a warning territory. One of the things we're doing to enhance this is enabling our customers to put all of that information in context in closer to real time. So instead of just having the ability to look at meters on a day-to-day basis, you can put them on a geographical plot so that you can better manage your workflows for addressing problem meters. You can add meters to a watch list so that you can understand and keep track of which meters are having problems or have had problems in the past. And then you can dive into a specific meter and understand its performance over time so that if there is a meter that's trending towards too hot and you've been keeping your eye on it, you know when it passes that threshold and you can send someone out to the premise to investigate it. So through the deployment of the meter temperature sensor with Silverlink Sensor Network, you can successfully proactively address meter temperature issues and prevent premise fires from occurring before they happen. In addition, this is the same type of data that can be used to power theft detection applications. So theft detection applications today use a lot of tampering alarms, usage anomalies, things like that. We want to start opening up more and more data flows to theft detection providers to enable them to make more advanced theft detection apps. So things that can use voltage, for example, to find theft behavior, or a wider variety of information that comes off the smart grid and that can be used to power these theft applications without having to do the complex integrations necessary to get that data. I think our next example is really interesting, and it's one of the first things that we've seen in the industry that can only be done using the power of the Silverlink Sensor Network. So we've got a number of partners that we've been talking about recently that use the Silverlink Sensor Network to power energy audits. Now, before, what you'd have to do if you wanted an energy audit is you'd have to have someone come to your premise and instrument every single appliance in the home. That can cost upwards of $400 to get an accurate reading of all the different electricity usage of every single device in your house. Remember, many homes have dozens and dozens of devices that are always on now. Instead, what you can do using the power of big data is you can take very granular usage intervals and compare them to known appliance usage signatures. We call them watt prints. And using pattern matching, you can actually separate out the different appliances without having to instrument each device in your house. So simply by having a very granular usage sample, you can use that to determine exactly how much energy every appliance in your home is using. That enables you to have better insight into your bill, as well as take action on your energy usage. So I'm going to show you a quick example here where we've done that with a partner. So this is the typical energy use. What I'm going to show you here, this is the typical energy usage profile that a customer today would get if they're logging to their utility. This is a 1 hour interval. Now, there's some useful insights here. You can see a couple spikes, but if you really want more information, you have to dive it in. You have to dial in the granularity of the data into a more granular basis. So now I'm showing you 1 minute interval. So 1 minute interval data, at that granularity, you can see a lot more stuff happening, right? You can tell exactly what these peaks are, and you can see that there's additional patterns that occur throughout the day on a very regular basis. Now, this may be still pretty confusing to the human eye, but when you run it through a computer-trained algorithm that has lots of information about what different appliances look like when they use energy, it can actually tell what the different appliances that make up this usage profile are. So we're going to do exactly that. We're going to run this through a partner algorithm. Our partner, PlotWet, which is one of the partners featured on the Silverlink Sensor Network, is able to take that information and disaggregate it into its different appliances. So you're going to see here them color-coded by appliance. And this is actually one of our friends at Silver Spring, his house. We've put this device on. What you're able to do is actually see that this in the dark blue here, this is his hot tub that he is running in January in Chicago. It's using a lot of energy, and for him that drives a large part of his bill. Now, if you were this person and you saw this energy use, a natural question that might occur is, well, how much is this actually costing me, right? I can see that it's a large portion of my energy use, but how much does this actually cost me on a month-to-month basis? And through our partner applications and by powering other applications sitting on top of Silverlink, we can actually answer that question. So this is a partner application that that PlotWet built in partnership with our data here. And you can see that it's actually broken out the amount that it costs for every appliance in his home. You can see that his hot tub costs him about a third of his total monthly bill. That's $48 out of $155 over 30 days. So that would be something that would be pretty concerning to a customer and that they would potentially want to take action on. Now, this is not only useful to the customer, it's also useful to utilities because they can use this information to better target their energy efficiency incentives to customers that have less efficient appliances. And they can also use it to target their demand response enrollment programs so that they can target customers with loads that can easily be curtailed. In addition, customers can use this tool to set energy budgets so that when, for example, their hot tub exceeds $50 a month in usage, it can send them an email or text message and help them better manage their energy use over the course of the month and by appliance rather than waiting to the end of the month to see a lump sum bill that doesn't really tell them why their bill may have grown or decreased. So better insights into bill management, better understanding of energy use to help drive better behavior on energy. Now, what we've shown you is our partner application. I'll note that we have other applications, other partners running similar applications on the platform as well. Here's an example from partner Bigley that also runs itemized energy bills for customers. And one of the advantages of the Silverlink Sensor Network is you can choose between multiple different application providers to help you determine what's best for your customers. Another example that we're very proud of that we've developed in partnership with Oklahoma Gas and Electric is our smart thermostat control solution and mobile app. So what this enables you to do through the power of the Silverlink Sensor Network is control your smart thermostat over the smart grid. So instead of requiring customers to buy an expensive thermostat, like a Nest thermostat that may cost $300 or so, you can enable them with Zigbee-powered thermostats in-home to control it over a common mobile application. So regardless of the different types of Zigbee thermostats that you might roll out over your service territory, you can create a common experience for a customer that's tied to your utility and that lets them control their thermostats over their smart grid. So we also have built a great corresponding mobile application with OG&E that's iPhone and Android compatible. And what this, not only does it allow customers to control their thermostat, it also receives peak pricing alerts and real-time information from the smart grid about what the current cost of energy is and how setting your thermostat may affect your energy use as well. So that's the type of information you can do with the Silverlink Sensor Network. And I think we'll pause there and ask if there's any questions.
So we have a couple of questions that just came in, and those are good ones. The first one is, do you need smart appliances in order to use PlotWet or any other load disaggregation algorithm? And the answer is no. I think that's kind of the key that we're talking about here. What we're able to do with the data flowing back from the meter is disaggregate it in a non-intrusive way, also non-intrusive load monitoring is its other name. And it allows us to be able to take that load and understand how to build an itemized energy bill from it. So no, don't require smart appliances. But I think that's kind of the key, because once you understand how the data flows, then you're able to take the work of a small company that has a group of experts that are looking at these patterns in voltage to try to identify what the specific appliances are. That's a small company that it would have a hard time negotiating a large deal and finding a way to fit themselves into the overall utility framework from an IT perspective. But if we're leveraging the platform that we've built and we're allowing that data to flow in a standard way, then smaller companies are able to participate in this. And that's back to the idea of an app store, which is crucial to the way this is going to be organized. So when we look at lots of companies doing load disaggregation algorithms for, say, quick-serve restaurants, excuse me, to do things like building and energy analysis, those kinds of things, because the data underlying it is pretty much the same, they can apply their algorithms to that in a much less expensive way and deliver those results to the utility and to the utility's customers.
I can take the second question. So the second question here is, does the network support data from devices other than meters? And the answer is absolutely. We built this with the intention of plugging in multiple different device types, and not only that, but data from other back office systems as well. So you can plug in data from your SCADA system, from your DA system, from the MDM, and use that data to not only provide other types of real-time data streams, but also provide context to the real-time data that you're seeing from the network. So for example, in the voltage example that I mentioned, not only can you see data from the AMI head-end system and from other AMI systems, but you can also plug in data from DA systems and understand which customers those premises may be affected by those voltage issues.
That's a really good, and I think if we switch that screen over, the other question that we got, is it really available? I'm sorry. Is it really available now? That's a really interesting question. The answer to that is yes. In terms of how we've organized the platform and our ability to feed those applications, we're currently working with several large utilities. We were able to produce, at our DTEC show, we had a couple of utilities present their specific programs that they're working on. Some of these are research and development, some of these are internal capabilities, and others of them are consumer facing. But the answer to that question is yes. The project that we're working with now with some of our larger utility customers involves load disaggregation across their verification and validation of 3 separate load disaggregation providers. They'll end up picking the one that matches for their particular needs, and then be able to move that into a wider scale. So if you're interested in working with us from a utility perspective, we do generally start with a proof of concept. We move it into a pilot, and then we look at how these things would actually be used. So long answer to the question, but essentially, yes, that is available now, and we're working on it. And I would say over the process of adoption of the customers that we are currently working with, we probably have 5 projects that we're currently involved with in terms of delivering results, leveraging the platform.
So another question that we're getting is, how does the system overcome network latency issues for capturing real-time data and getting it back to the utility? So that's a great question. So there's a variety of ways that you can do this. One of the ones that we talked about was distributed compute on the network infrastructure. So take the voltage example. You might like to have voltage data to power a CVR application every 10 seconds. You might want to have a voltage interval every 10 seconds. Or in the load disaggregation case, you may want to have usage information that's gathered every minute or even more frequently than that. Instead of having to pull all of that information across the network, which would be, in fact, very network intensive and potentially tax some of the bandwidth, what you're able to do by leveraging some of the computing power on the NIC is compress that data. And compress it in a couple interesting ways. So you can use standard compression algorithms, but you can also just put some rules on the NIC that tell you when the data that you're interested in occurs. So for example, instead of sending every voltage interval back, you can send just the sags and swells back and an occasional summary set of information to tell you how the voltage is doing. That enables you to power an application like CVR by looking at exceptions on the network rather than focusing on gathering all of the data and then processing it in the back office to find the exceptions. So not only do you have to bring less data back that way, but you're also bringing the data back that you actually need to power the applications you're looking for.
Yeah, and I think there are a couple of questions that revolve around the network capability and the ability to bring the data back and the networks that are being used. And I think that the easy way to answer some of those is to say that it's not specific to any particular network. It really depends on the application that's involved. So controlling a smart thermostat is going to be different than doing load disaggregation in certain respects. So we're network agnostic when it comes to that. The ability to bring the data back will also depend on the frequency and what needs to come back. And if you're comparing that with, say, historical data to do rate comparisons, then that all would take place in the back end. But I think in terms of network capability, what we've seen with our customers is that there's, in general, a fairly significant amount of capacity available on the network as long as it's timed correctly and it's not interfering with the meter-to-cache process. And that's just a question of how you make the network work.
We have another question on the partner program, Scott, and kind of how people get involved in the partner program and whether partners can resell applications through our App Store. So I think one of the great things about the Silverlink Sensor Network is we've got a great partner program that we're opening up to a lot of smaller companies that actually, if you're on the webinar today and you're interested, we've got a great way to register for that as well. And we're going to be launching in the next few months a developer program that helps different partners get in and more easily connect to this data and get access to all the information they're looking for. So a few more questions it looks like are coming in on the load disaggregation front and how.
Yeah, and I think, Alex, why don't we just go through that in a little bit of detail in terms of explaining how the load disaggregation sensor actually works, what data channels are in there, and how we leverage that, and why it's important to have the 1-minute interval. I know you touched on it a little bit in the demonstration that we just did, but I think there's a bunch more questions related to that. So if we can dive in a little bit on the load disaggregation algorithm, which is being supplied by our partners. We're supplying the sensor, the load disaggregation sensor, and tell us a little bit about what's included in that sensor and how it works. And then.
Absolutely. Well, the main challenge that we've run into in working, and the challenge that we found working with the disaggregation partners, is they've just had trouble getting access to data that's granular enough to power their algorithms, right? So the thing about disaggregation is the more granular data that you get, the better the results you're going to look at. So if you're looking at data that's gathered once an hour, the amount of insight that you'll be able to tell is pretty limited. You can kind of see when heating or cooling turns on. You can kind of see when some of the base load is on. But it's really hard to see things like refrigerators, air conditioning units, electric vehicles, right? And when you go down to an interval of 1-minute data, you can start to see things like refrigerators and lighting and heating, cooling in more detail and provide more accurate results to customers. So it's really by taking that data off our network and providing it through a common API and providing really granular, near real-time data that enables them to power more accurate, more timely insights for the customer on their energy use.
Well, and I think the other thing is we've gotten a bunch of questions about this is not a one-size-fits-all kind of solution. This is going to be aimed at very specific segments of the customer base for people that opt in and want to know how this technology can benefit them. And Alex mentioned this a little bit earlier in our presentation, but it's very likely that there will be a small group of people doing this at any particular point in time, and that it's important that the utility has the ability to address this not just from the customer's perspective in terms of delivering an itemized energy bill, but also in terms of handling bill shock calls. There's a whole group of customer issues that can be resolved if they know the answers to some of these questions when the person calls in and has a question. So the issues around data privacy, of course, are important. Confidentiality of the data is also crucial. Those kinds of questions are almost always addressed through opt-in programs. And we haven't seen a utility who's interested in this technology not view it as an opt-in program where the consumer is specifically asking for this kind of capability. It's sort of the next logical step in many respects to the Green Button Initiative, where consumers can request their data. We're just simply going to give them a way to do it that's easy and that gives them an insight into the exact amount of energy that they're using and corresponding to which appliances.
That's right. And there's a question on kind of consumer reaction to this. We had a large utility partner do a survey of their customers on whether or not they would like itemized energy billing and where it ranked as far as their priorities. And over 70% of them responded positively that they would find itemized energy billing to be very useful for their monthly energy use. And I think that's an interesting insight when you think about, if you go to a restaurant or if you were to get your AT&T bill on the month and it weren't itemized and you just got one lump sum bill, I think a lot of folks would say, that's not really the level of information that I'm looking for from my billing, right? We send customers a bill every month that really is only one lump sum for their energy use. And I think once you provide that level of detail into what's driving their energy use, customers are going to find a lot of benefit out of that as well.
And there will be always a group of customers who aren't interested in this kind of capability. And so we're cognizant of that, and as are utility partners. And it doesn't need to. But I think for the people that are interested in an itemized energy bill, for the ones that are looking for rate comparisons, that want to understand if they make a modification to what they're doing in their house, how is it going to affect them? And is it going to actually lower their bills? Those kinds of questions are important for the utility to be able to resolve positively for those customers that are interested. And I think that's kind of a key. But I'm not in any way minimizing the issue. I think it's one where there will be the adoption of these kinds of technologies will take place over time with the folks who are most interested in them.
Okay, so there's another question coming in. There's a series of questions on kind of what type of data access do application partners get when they sign up for this. And I think one of the things that we're going to do through our developer program that we'll be talking about in the coming months is providing sample data sets that partners will be able to use to develop their apps against before they even are able to engage with a utility partner, right? So you'll have access to fairly granular data that enables you to build an application as if it's running on a real smart grid, but against a sample data set so that you can create a demonstration and more easily use that to help get closer to market. Once you do engage with a utility customer, we're going to have a conversation around what type of data the utility has available and being able to pipe that into the SilverLink sensor network. A lot of that data that's flowing off the smart grid today that's the same data that's going to be powering the SilverLink sensor network and available to application partners to use as part of their application as if the utility provides that permission and is able to accept that application.
And I think we've got time basically for one more question here in terms of moving forward. So we're trying to, there have been dozens of questions, and so we apologize for the pauses, but it's basically trying to get an answer to the three questions that are all basically asking the same thing in slightly different ways. So I think the one thing that's important from our perspective is, and once again I'll emphasize, is that the nature of a platform requires application developers to be able to access it easily. And so from our perspective, the use of standard RESTful APIs that are common in internet networking technologies is kind of a key. So when we design the sensors, those sensors are going to combine different types of data into different channels, and then that's going to be supplied and through that interface to an application that's capable of consuming that. And we're going to let that application be able to define the type of data that they need. Some might be historical, as we mentioned earlier. Some might be closer to real time. And it's easier always to talk about something in a very specific example, but to generalize it, to take that data and then to be able to leverage it in an application where they don't have to figure out how to get the data in the first place, but how they can actually leverage it in a way that brings it much more close to the consumer or the internal utility problem that's trying to be solved, whether it's voltage on a particular transformer, whether it's sag swell information, whether it's outages, or whether it's load disaggregation. Those are the kinds of things that we're interested in solving, and I think what you've seen so far is a way to combine those so that you can address them all with the same platform. So I hope that answers your questions. I hope that if you've got any sort of of much more specific questions. Obviously, the webinar format is difficult for us because we're not sitting in a room with everybody and we can't see how everyone is reacting. But please feel free to contact Alex or myself. I believe that information is included at the end of will be included at the end of the at the end of the presentation. We'd be really happy to answer your questions. There were some questions about utilities that were currently using this technology. Obviously, we can't talk about that in a broad format, but we would like to be able to answer some of those questions. I know lots of utilities are interested in sharing information about the kinds of programs that they're interested in, and I think that would all be very helpful towards understanding how this technology could be adopted even more quickly.
Great. Well, thank you guys, everyone, for attending. We definitely appreciate you guys taking the time to learn more about the Silverlink Sensor Network. We'll be excited to be sharing more information about this in the coming months, and a recording of the webinar will be provided and emailed out to be made available. You'll also see some resources on the left-hand side of your screen if you'd like to find out more information in the meantime, and we'll look forward to following up with you at the next venue. Thank you very much.